Hi and welcome back to Neil's Notes. In the last couple of videos we looked at how to get a camera working on a Raspberry Pi and also how to build a web server serving up a video on a Raspberry Pi. In this video we're going to put these two things together and create an application on a Raspberry Pi that will let us stream video from the camera attached to the Raspberry Pi to a web page on another device. As always, all the notes to accompany this are available in neilsnotes.net, and if you go to neilsnotes.net and look for the .NET Pi camera server, you will find all the code that we're going to go through in this video. And if you want to follow along, this should help you with a step-by-step guide in text along with what we're going to do today in this video. So let's get started. Here I am on my Raspberry Pi. Let's open the terminal, which seems to be where we always start. And I'll zoom that in to get going. And let's go to where we have our code. And let's make a folder for this application that we're going to build. We'll call it .NET PiCam server. And then we can change directory to that server. And then in here, which is now empty, we're going to use .NET New. Now, we've used .NET New Console to create console applications, and we've used .NET New Web to create the web server application, but we're going to do something a little bit different. We're going to use Web API in this video to create an endpoint, an API endpoint that can serve the video content from our camera attached to the Raspberry Pi. So this will now go and create the infrastructure, a template that we need for a Web API project, and we'll just have a quick look and see what has that generated for us. Well, actually it's generated a weather forecast controller, which is a dummy API. It doesn't actually give us the weather, it gives us some random pretend weather attached to our normal program. So it's given us a template of how to build a Web API application, but we are going to have to change this, and we're probably going to delete some of this because we don't want a weather forecast, we want a camera video feed. So let's open this in Visual Studio Code, and then we can get going with working out how we want to change it. So we could start by opening a terminal in Visual Studio Code and building the templated application that was generated for us and running it. And when it runs, it should give us a web service that's available on a URL that we can access from Chrome or our local browser, which would be something like http:// and it will be localhost something or other. So if we wait for which port it's going to generate this on, oh, it already has, so we can just see here 5035, and then at 5035 there won't actually be anything. It's at an endpoint, which is weather forecast, that it's going to give us, so this is the API endpoint, some random weather information that's just made up based on some random number generator. But we want to change this. We don't want it to give us a weather forecast, we want it to give us the video from the Pi camera. So we can close this, go back to Visual Studio Code and stop running. And we can see that the way this works is in the program, it sets up controllers. Now, by setting up controllers and mapping the controllers, it is looking for controllers in the controllers folder, and you'll see here this is a controller route called weather forecast controller, and that is what tells us that that first bit, weather forecast, is what we need in order to access that endpoint. Now we want to change all of this to, instead of being a weather forecast controller, be a video controller. There's also a class down here which is called weather forecast, which is really just creates the framework for displaying, or the data to display for a weather forecast, and we won't need that either. So we can just delete that file, that's unnecessary. Yeah, move it to the trash, get it out of here, and we can rename. F2 is actually the rename of weather forecast controller to video controller. Okay, so that's change that, and we can rename the class to video controller. We can actually get rid of all of this. We'll keep the logger because we might want to log things out, although now the logger is based on a video controller, not a weather forecast controller. And we'll keep the constructor, and we'll just rename this to video controller, and of course the logger it takes will use a video controller, not a weather forecast controller. Great. Now we've got a constructor, but here you can see the HTTP GET is to get the weather forecast, but we want to get the video, and so we need to change this method to return something that's useful for us as a video. And right now, not really sure what that is, so let's just change our get method to return void and just take out all of the code inside it so that we have an empty method. And actually, if we go and build and run this now, and then go back to our browser, open up that new tab, HTTP /5035, and our new endpoint is video. And took a little bit of time, but there it is. So it's telling us it's not secure, that's expected, but it's found the endpoint and there's nothing to render. Okay, great. So let's minimize the Chromium window, go back to Visual Studio Code Terminal, Control-C, and finish the web server from running. In the video and notes where we use the camera from the Raspberry Pi, you may remember that we needed to include some references to packages to support accessing the camera. And these are the system device GPIO and the IoT device bindings packages. So we need to add those to our CSproj file. That's our project, and that tells our project that when it compiles it needs to pull down these packages. This is using NuGet. Pull down these packages so that they're available for our application to run. To support using the camera, we're going to create a new class in our project which we will call camera. So in here, let's add in next to the program class, let's add another class called camera.cs. Now this is going to do all the hard work of accessing the camera, collecting the frames from the camera available for our endpoint, our web endpoint, to serve them up. And so a lot of this code should look pretty familiar if you watched the how to use a camera on a Raspberry Pi. So we're going to start by adding the IoT device media namespace, and then we can define our new class, camera class. And then in this class we're going to need to set up all the same things that we did to use the camera last time. So we need the video connection settings, which we will just call settings. We need the video device itself, which is the camera, but we will call it device here. And we need a cancellation token source to enable us to cancel capturing the video when there's nothing attached and nothing is watching it. There's no point in having the camera switched on the whole time and trying to serve up if there's no endpoint to serve to. And so this is going to be something that we only really need one of for the runtime of while the camera is working. Then we're going to create an event. Now this enables another piece of code to say, if I want to know when a new image is available, can you please tell me? Can this camera class please tell me when a new image is available? So let's call it the new image buffer ready event. New image ready. And if you remember, we used something like this in the video when we were capturing the camera content, and we're going to do this again in this exercise, but we need to also make it available outside of this camera so that the new image buffer ready, so that the code that's serving up the web content can hook into this and know that there's a new image available or a new frame available. And when no one is connected, so when someone disconnects from viewing the camera content on the Pi, then it can remove the event handler. So new image buffer ready, same as before, except this time we're going to take away the handler. So now we've got an event handler for the, I missed a dot there, for the video device new image buffer ready event. So an event handler for this event that can be accessed by another piece of code in this application, and that other piece of code is actually going to be this video controller, which we'll come back to in a minute. So let's create the constructor for the camera, and we need some settings, so we can create a new video connection settings object, which we will set up with a bus ID. That's the bus that we're using to connect to the, just make that clear, a bus ID. we need to define the capture size. So how big do we want this video capture to be, and we'll just do something simple for now, 640 by 480. I'm always cautious when you start off to keep the video reasonably small. Don't try and go straight for full HD, because while you're testing things out, you don't want a lot of activity going on that's not necessarily relating to the code. So pixel format, and we're going to capture JPEGs from our camera, so it's JPEG. Okay, so now we've constructed our video connection settings, we can use those to instantiate a device. If you remember, video device has a create method on it, whoops, that takes these settings to define how the camera should be set up. And then the other thing we can do is we can say device image buffer pooling enabled equals true, and this is really just a performance enhancement to enable it to reuse image buffers rather than recreating them and deleting them the whole time. The next thing we're going to want to do is some mechanism to start capturing, so that the web piece of our code can say to the camera, I want you to start capturing content from the camera, and so it becomes available for me. So we're going to create a start capture method that we can call from the video controller to start capturing the content, or the stream of content, the images from the camera. Now, if the camera is already started, we probably don't want to start it again. So we're going to start by saying only if the device is not, so if the device is not already open, then we're going to say to the device start capture, whoops, continuous, and this will start a continuous capture of images from the camera. And then what we want to do is say, if we don't have the device capturing, so if the device is capturing, I need a dot there, so if device is capturing, but actually we want not, so if the device is not capturing, then we're going to start capturing. If you remember from a previous video on the camera capture, we actually did that in a separate thread, and we're going to do something similar here. So we're going to create a new thread to capture the contents coming from that camera, and that thread will have a method that will you call device capture continuous, and it will take the token source that we created earlier to enable us to stop this by cancelling that token. So when we, in our code, say to the token or signal to the token to cancel, that'll tell this thread to end and stop capturing continuously. And then what we want to do with this thread is start it. We have a start capture method. We should probably have a stop capture method. let me just sort out the spacing a little bit. So stop capture, doesn't need to take any parameters, and we only want to do this if the device is capturing. So if the device is capturing, we can stop it. Of course, if someone calls stop or some code calls stop capture and it's not capturing, then there's nothing to do. So we will say token source, that's the cancellation token. Let's call cancel on that, and that'll end this thread that we started above. And then we'll just recreate that token source so it can be used again for a new set of capturing. So someone could start capturing, stop capturing, and start again. You don't want, when they start again, for that token source to already be cancelled. And then of course we need to, on the device itself, call stop capture continuous, which is a method on the device to stop it from capturing images from the camera. So for now we have the camera class that should have everything it needs to start capturing images from the camera and stop capturing images, and have an event source that our video controller can listen to capture those images and then send them over HTTP as images to whoever is browsing to that endpoint. If you think about it, the Raspberry Pi only has one camera, and so the camera really represents the camera on the Raspberry Pi, which is great, but you can't have more than one camera. And so really what we should do is, in our program, set things up so that there can only be one camera. And the way we can do that is by adding a singleton to the set of services that are available in the web server, and that will be the camera device. So this singleton is a pattern in software development that means there's only ever one of them. And what we did here is we added to the web server, the web application, to the list of services that are available, there's a camera. And so now when we want to use this camera, we should be able to get it from our video controller. Head over to the video controller itself, and in the video controller we have a logger. We can also add to this a camera. Now you'll notice that the templated code uses underscores for member variables of a class. We may as well stick with that format for now. I'm sure everyone has different ways they like to write their code. This is fine for now. I just follow along with what we got from the template, which is absolutely okay. Now, because we added that singleton to the services, it lets us do this, which is say, as a parameter to the video controller being created, I want that camera. And because the video controller is created by the web application, it knows, oh, it wants a camera, and I have a service that can supply the camera instance, which is a singleton from the previous step, and make it available. So now we can have camera, the local camera equals the camera that's passed in. So now that singleton that got instantiated is available for us to use in the video controller. Great. Now, to use this in our video controller, we're probably going to need to add some more namespace for us to take advantage of the IoT. So let's add IoT device media. We're pretty sure we're going to need that. We're also going to add, and this is partly because I know what we're going to do next, we're going to add Microsoft ASP.NET Core namespace for HTTP features. So ASP.NET Core is the core technology on .NET 6 that's running our web application. We're also going to include system buffers, and this will help us with some memory manipulation maybe, and we'll include system.text. Make that clear, text, so that we can access some text capabilities of the system. So now we need to get into doing, I guess, really the hard work in the get method. We'll start the get method by setting up a buffering feature for the response, because we're going to need to respond back to whoever's making the request on this video endpoint, and what we don't want is buffering. Why don't we want buffering? Because we're going to set a sequence of images. We don't want the browser to go, oh yeah, I've seen this, I don't want any more updates. We want it to, every time we send something, for it to say, oh, I need that as a new thing. And then we're going to need to build a response for the HTTP request. So this, when this gets called on HTTP GET, it's got to generate an HTTP response. And so we're going to take the context of the request and start building up the response. Now a status code of 200 is, okay, success, that's good, so we're going to say we're successful. We're going to return a certain content type, and we're going to add some connection or some headers, the first one being a keep alive connection, because while we're streaming images from the camera, we want to keep this alive, and we also want to say there's no caching, please. And this content type is a multi-part, so it's going to come in separate parts. Each frame is going to come separately, and we've defined the boundary as -- frame, and we'll see why that's important in a minute. And then we want to set up our camera, and remember we created that new image buffer or new image ready handler. So if we go back to the camera, we have an event. Oh, did we call it new image buffer ready event? Maybe we shouldn't do that, because that's the same as this. So maybe we should just call that new image event. I think would make more sense, or maybe just new image ready. So why don't we change this to new image ready, and then go back here and say camera new image ready. And now we need to create an event handler or something to capture that. So if we do plus equals right frame, well, we're going to need to create this right frame method. So let's just make a note of that. It's going to be, well, it can be private, it doesn't matter what its accessor is. But it needs to be an event handler, so right frame is going to take an object which is a sender and a new image buffer ready event args. Let's take some arguments, which we'll just call E, which is kind of a default in .NET. So this right frame method will get called every time a new image is ready. And I might just, because we're going to need a bit more space to look at code, just make that terminal a little bit smaller as we keep going. Okay, so now I've got this method set up. I should probably set up the camera to start capturing. So we're going to do this in a try catch setup, because if you remember or you followed the video on using the camera previously, sometimes the camera just fails, or sometimes other things happen and runs out of memory and an exception gets thrown. We want to catch that and we want to handle it. So in fact what we could do here is we could use the logger that's passed in to log some information. So we could log that an error has occurred, and we could even start to get a little bit clever and say, what is this error? So error in capturing camera, and then we could put the exception information in there, so if something goes wrong. But that's the unhappy path, I guess. Let's have a look at the happy path and what we want to do here. So we could also log here. We could log information to say that we're going to start capturing video. Start capturing video. So if we're watching this as a developer running the code, we could actually see when someone has connected. And then we'll call camera start capture. That was the method we created in the camera object to start capturing. And then we're going to create a little while loop that says while the HTTP context request aborted, so while it's not aborted and there's not a cancellation request, cancellation requested, oops, we're just going to spin. So we're actually going to do nothing. So while there's no request aborted, we're just going to sit here. Now when a request is aborted, something will happen and it will probably end up in the exception handler. And if we're kind of expecting that, which is not a great way of doing it, but it will work for now, we can put finally that will always get called after the exception handler or this code has finished, which is to close down the HTTP request. So we say to the HTTP context response body close, and that ends the body of our HTTP message. And we could actually log some information here as well, right? We could say, just for the sake of us being able to track this, we could say we'll stop capturing video. The other thing we should do, I guess, is we should that new image ready event, we should take away our event handler. That right frame event handler can go. And we should probably also tell the camera to stop capture, that other method that we wrote to accompany the start capture. So the next thing we're going to need to do is actually fill in the right frame method. This method, probably similar, we probably should take a similar approach with putting a try catch in here. And in fact, I think in the previous notes where we used the video, we used the camera on the Pi, we realized that it's possible to get in a position where the camera is still got something in its buffer, but actually it's being disposed, and so there's a message saying yes, there's something ready to read, but actually the camera's already gone, the camera object, the device object is already gone, and so we have to handle this object disposed exception, which we can actually just put here, expected when the buffer has not been read yet, device is disposed. So let's go back to the happy path, and here we need to somehow get the contents of the image buffer and write them out to a stream over HTTP. And so we're going to do something like this: HTTP context response. So that's the response that we're making to the request. We can use the 1T body writer method to write async, which means we probably need to await on this. I'm going to create a new method called create header, because this is going to happen again and again each time with the length of the buffer that we're going to write. And this is sort of important because we need to tell the browser that's reading this what to expect. And so we're saying we're going to, for each frame that we write, we're going to give it a length and put that in a little header so that it knows what to expect. Now, because we need to await this because it's async, we also need to make this method async as well. So we'll come back to talk more about async and awaits, I guess, in some future video, but for now we're going to need to do this, otherwise things won't compile correctly. We also need to do something similar again. Instead of writing out the header, we need to actually write out the body or the image itself. So e.image buffer, and we'll just write it out as a memory stream, and we can take a piece of it. So how much of that do we want? We'll take from 0 point to the length provided, and it's better if you spell it right, to the length provided, and that's what we want to write out. So we're going to write out the image buffer from the start to the end point. And then I guess we should write out something at the end to say this is the end of this buffer. So let's create another method called, we used create header, let's create another method called create footer, which will write out the end of the image. So for every frame we'll start with a header, then we'll write the frame contents, and then we'll finish with the footer. Now, if you remember, we set up a pooling for the images when we set up the camera, and so I'm going to do something which is to make sure that each of this set of buffers or frames that we get gets returned into the pool. Once you've finished using them, you're supposed to return these back into the pool so that it's available to use again for another image capture or another buffer capture. So what's happened here is we're just now explicitly saying I finished working with this image buffer, I can return it to the pool so that it can be reused and I don't have to use more and more memory the whole time and wait for the garbage collector to catch up. So now I guess we need to create this create header and create footer methods. So let's go ahead and do that in our code. They will return a byte array that will get written out into the response body. So create header, and what did that take? That took the length of the image buffer. So let's create a string which we will call header, and what we need to put in here is something that identifies this is a new frame. And if you remember up here we said a frame begins with dash dash frame. That's the boundary of a new frame. So what we can do is we'll create this new string, which will probably be quite long, frame. Then we want to, after the frame, put a carriage return and a new line, and then we'll say the content type. So what is this frame of type is image, JPEG, and this is an HTML type, I guess. And then we'll do another new line, and we'll say what is the content length. Content length. So this is telling the browser, the receiver, that we now have a length for the content, and that's the length that was passed in here, of the image buffer. And then we're going to just put a couple of new line breaks so that it's got something to respond on, or to identify there's a gap. So we've got a frame, we've got some content, and then we'll put the actual block of the image buffer, and then we'll do the footer. But this is a string at the moment, and we need to return it. Return that string as ASCII encoding. So encoding, and we'll get those bytes for that header string. Okay, so now we've got the header being returned. The next thing we need to do is something similar but for the footer. So private byte array, create footer, and then here we can return, same again, we're going to want the encoding dot ASCII get bytes. Now I'm just going to hard code the string in here, because in the header when we create it we actually want to inject the length value, but here for the footer it's actually going to be the same string every time for now, which is just a carriage return and a new line, so that we got another gap at the end of the image buffer before we start creating the next frame. If we've done everything correctly, we should now be able to run this. Okay, so now we should be able to go back to the browser. If we refresh this page, you can see it said start capturing the video. It's got an issue with one of the headers, but overall it looks like it should be, there we go. So now you can see we're capturing the video. It's actually captured a frame, but it's stopped. So there's an issue with the way we've set our headers up because we're not secure. But we kind of expected that because we know we have a security issue. But it is capturing a frame, and you can see there if I just run it again, it should capture one more frame. Okay, great. So now let's fix this issue with not having so we'll just stop that, and let's fix the issue with not having a valid certificate is really the issue here, because it's saying HTTPS but it's not secure. So we'll go back to Visual Studio Code. To get the website to appear to have some certificate attached to it, although it's only really a dev certificate, so we wouldn't want to do this for real, you can run this .NET devcerts https --trust command. Now actually in Windows it will actually come up and try and tell you that this needs to be trusted with a little message. It doesn't automatically do that on Linux, and Raspberry Pi is a Linux box. However, just by doing that, we can run the application again and then head over to refresh this page, and you can see it's picking up the video, and now you're actually capturing some form of video in real time. It's just looking at my desk, which is a little bit boring at the moment. However, you can see that it's working. Okay, so we can stop that, and you can see in the messages coming out from the server that, well, this is our camera server, that it starts and stops capturing video. So let's finish that, and I guess the other thing we might want to do is to actually view this from a different machine. And if you watched the previous video, you know that we can set up the URLs for this. So I'm going to do HTTP so we don't have to worry. So we're just purely on HTTP 192. Actually, yes, let's just go back and find out what is our host name with a lowercase h. So we're 159, so we can .NET run URLs equals HTTP : 192.168.1.159:8080, and that will then mean that from another machine, which we can test in a minute, we should be able to access the camera running over HTTP. Now of course this is not secure, and this is really just a toy at the moment, but we're showing how to get a camera running from a Raspberry Pi and streaming the image over to any other machine. So now you can see we're running here. So let me swap over to a Windows machine. So here on my Windows machine, if I go to a browser 192.168.1.159:8080 and make sure it's HTTP, (192.168). Ah yes, because it needs to be video. Remember, it's the video endpoint that we're accessing. And there I now have from my Raspberry Pi the video being accessed on a Windows machine. Now if you don't have another computer, you could even do this on a tablet or a phone. Just remember that it has to be the video endpoint and it has to be HTTP, which means it's not secure. So you don't want to do this out in the wild or in a kind of production type environment. But just as a test and as a experiment, this is great. We now have the camera working on our Raspberry Pi and streaming over a web server. And now back on the Raspberry Pi, we can close the server and shut down. Now remember, this is only really going to work on one endpoint as well, because as soon as two endpoints connect, while they may work while they're connected, as soon as one disconnects, it will disconnect everyone, because we haven't really thought about any kind of concept of session or management of number of people connecting through to the camera. There's one camera, and as that camera gets used and stopped being used, it starts and stops the camera, which is obviously not great as a multi-user web-served, image browser. But we managed to work out what the code was to make this work, which is a good first step. And maybe in a future video we'll look at how to make this a little more robust and turn it into something that you could use as a more production ready type of application. Thanks for joining me on this adventure. Hopefully you learned something. Hopefully if you did follow along, you now have a .NET application running on a Raspberry Pi that can serve camera images as frames for a video that can be displayed in a browser on another device. Of course, all the notes are in neilsnotes.net with all the code, so you can go there if you get stuck and copy the code out of neilsnotes.net and get your application up and running. Once again, the caveat that this is really only a toy. This is certainly not a production piece of software. There's a lot of security issues with the way this is set up. It really is only working over HTTP, and it's doing a bunch of things that really you wouldn't want to do in a production environment. However, as a learning experience, hopefully you learned something from it. I hope you'll join me again in a future video, and look forward to doing some other experiments with .NET on a Raspberry Pi. Thanks for watching. Bye.